Hi guys, welcome to this podcast, and today we will be talking about the atom. We will do some calculations based on this, so you may want to grab yourself a pen, some paper, and a calculator. So, what is the atom made of? The atom is made up of protons, neutrons, and electrons. For this course, you will need to know the mass and charge of these particles and where they are located. Protons have a mass of 1.67 times 10 to the power of minus 27 kilograms and a relative mass of 1. It has a positive charge of 1.6 times 10 to the power of minus 19 and it is located in the nucleus. The neutrons have a mass of 1.67 times 10 to the power of minus 27 kilograms and a relative mass of 1. It has a relative charge of 0, and it is located in the nucleus of the cell. So the nucleus of the cell is made up of protons and neutrons. Electrons have a mass of 9.11 times 10 to the power of minus 31. So they have a relative mass of 0. It has a charge of minus 1.60 times 10 to the power of minus 19. So they have a relative charge of minus 1. They orbit the core, so they orbit the nucleus of the atom. The proton number, which is often represented with the letter Z, is the number of protons in the nucleus. Different elements have a different number of protons. In a neutral atom, the number of protons is equal to the number of electrons. The nucleon number, also known as the mass number, is essentially the number of protons and neutrons in the atom. The symbol used to represent it is usually an A. The nucleotide notion is used to summarize the element's atomic structure. The nucleon number tends to be at the top, the proton number at the bottom, next to the element symbol in the nucleotide notion. Using the nucleotide notion, if you want to calculate the number of neutrons, all you need to do is take the proton number away from the nucleon number. The specific charge of a particle is the ratio of its charge to its mass. It's given in coulombs per kilogram. The specific charge is equal to the charge divided by the mass. Okay, let's try a question. Calculate the specific charge for the nucleus of a carbon-12 atom. We know that the mass of a nucleon is 1.67 times 10 to the power of minus 27 kilograms. We can therefore say that the mass of a carbon-12 nucleus is 12 times 1.67 times 10 to the power of minus 27, which is equal to 2.004 times 10 to the power of minus 26 kilograms. We also know from earlier on in this podcast that the charge of a proton is 1.60 times 10 to the power of minus 19 coulombs. So, the charge of a carbon-12 nucleus is equal to 6 times 1.6 times 10 to the power of minus 19, which is equal to 9.6 times 10 to the power of minus 19 coulombs. Now that we have the charge of the proton and its mass, we can substitute them into the specific charge equation. The specific charge for this nucleus of carbon-12 is therefore 9.6 times 10 to the power of minus 19 divided by 2.004 times 10 to the power of minus 26. This is equal to 4.7904 times 10 to the power of 7, which is equal to 4.79 times 10 to the power of 7 kilograms to the power of minus 1. Okay, so here's a question for you to try on your own. The specific charge of a carbon-12 ion with 8 electrons is what I want you to calculate. Pause now if you think you can do this by yourself, and if not, I'm about to explain how we get the answer. Okay, so the specific charge is 1.5968 times 10 to the power of 7. How did we get this? The mass of the carbon-12 ion is 2.004 times 10 to the power of minus 26 kilograms. We ignore the mass of the electrons as it is relatively small, and instead just use the mass of a nucleus. The charge of an electron is minus 1.6 times 10 to the power of minus 19 coulombs. The total charge of a carbon-12 atom is thus 6 times 1.60 times 10 to the power of minus 19, add minus 1.60 times 10 to the power of minus 19, which is equal to minus 3.20 times 10 to the power of minus 19, minus 3.20 times 10 to the power of minus 19, divided by 2.004 times 10 to the power of minus 26, will give us our specific charge, which is equal to 1.5968 times 10 to the power of 7. Okay, so one last thing before we end this podcast. I would really like to talk about isotopes. Atoms with the same number of protons but different number of neutrons are called isotopes. The number of neutrons affects the stability of the nucleus. The larger the number of neutrons compared to the protons, the more unstable the nuclei becomes, and an unstable nuclei can become radioactive and decay in an attempt to make itself more stable. Isotopic data is the amount of different isotopes of an element in a sample. We have now reached the end of this podcast. Thank you so much for listening and have a wonderful day. Hi guys! Welcome to this podcast, and today we will be talking about the atom.